In this masterclass, we are going to go through everything we have to know about Power BI as data engineers. Well, designing the dashboard is going to be a very small part of this video, and the rest of it is going to be the technical stuff like data transformation using Power BI, data modeling, creating measures, and deploying reports from development environment to production environment. By the way, links for every resource that I'm going to use in this video will be available in the description. Without further ado, let's begin.
Before we dive into the first topic, let me tell you how this masterclass goes. This class has 7 to 8 topics, and for each topic, I'm going to explain the theory part first, and then we jump into the practical part where I demonstrate everything on the screen while I talk about what I'm doing and the steps to follow. And by the way, if you want to get the practical experience as well, you can just follow along where I guide you through every single step that I do. And also, all the files that I'm going to use in this masterclass will be given to you through GitHub link that I will paste in the description. So you can just click on the link and get the files right away. And when I explain the theoretical part, if I feel something is hard to explain vocally or through words, I'm just going to draw something on the screen or use a flowchart to explain that particular concept. Our first topic is foundations. There is something we have to know about before we step into the technical part of Power BI. I'm sure you guys know there are a lot of videos on the internet and YouTube about Power BI. And most of these videos make people think Power BI is just a visualization tool where we import data and create reports in it. But in reality, Power BI is something more. Power BI is a multi-stage data system. When I say multi-stage, Power BI has 5 layers in it, 5 major layers in it. Firstly, ingestion, data ingestion. We use Power Query, an integrated tool in Power BI for data ingestion. So that's the first layer. And data modeling. We can do data modeling in Power BI. We can relate multiple tables, and we can also manage the cardinality and all that stuff. And third, we have query engine. We can use data formulas, DAX formulas to query the data. And fourth, we have visualization layer, which everyone knows about. And fifth, most of the Power BI users don't know about this layer, which is Power BI can also act as a deployment platform, where after we're done with a dashboard and we want to deploy it, we can deploy it from development environment into production environment. And I'm going to demonstrate how in this masterclass later. So these are the 5 major layers that Power BI is known for. Now, let me show you something. It's not this one, it's this one. Here, this is the flow that our data follows in Power BI. First, we'll have the raw data, which will be coming from the data source. And then we have ETL. And ETL layer is managed by the tool Power Query. Like I said, Power Query is an integrated tool in Power BI which handles ETL. If you don't know about ETL, ETL stands for extract, transform, load. Extracting means extracting the data from the data source, which basically means it does the data ingestion. So it extracts the data first and then transforms the data, clean the data, and then load the data. So that is responsible for ETL. Power Query is responsible for ETL. And then there is data model. We can model the data. Then we have DAX engine, which we use for data querying the data, creating measures, or creating calculated columns. And then we create reports. Then we have deployment layer, which is service. And I represented it as a service because we use something called Power BI service to deploy our dashboard. That's how the usual flow goes. But we don't use most of the layers in this flow because in this modern era, this flow is good for the data that is in a medium or a small size. But if the data we are dealing with is big data, which is a huge data, this model doesn't work. This is fully Power BI native model. And the modern model we usually use is this one. We get the data from the data source, right? So we have the data source. We get the data from the data source. We do ETL separately, not using Power BI. We use something like PySpark for big data, or DBT, or any tool like that to transform the data. Here I said ETL, but it can be ELT too. ETL stands for extract, transform, load, and whereas ELT stands for extract, load, transform. They both are similar, but yeah, this is our DE layer, the main part. So we do that separately because the data we are dealing with in mostly not be a small amount. It'll be huge. So we can do those transformations in Power BI. So we use separate tools like them, the PySpark and DBT for the ETL layer. And then after transforming the garbage data into a business ready one, we store the data somewhere in data warehouse or data lake. From there, we connect Power BI to that data warehouse to get the data into the Power BI and then work on it. We create visuals, or we use DAX to create measures, data model, and then we create visuals inside, visualizations like dashboards or reports, and then we deploy it to the end user. This is how the flow goes in the modern data stack, modern era. But there still are a few companies where they use Power BI fully, entirely for their whole data pipeline. If you go to a job or apply to a job that says Power BI data engineer or Power BI data analyst, you are basically applying for a job that follows this flow, everything inside Power BI itself. But in modern data stack, we do. Even in the modern data stack, we still use Power BI, but we don't usually use this layer. We don't use Power Query for ETL. We just use Power Query to ingest the data into Power BI. That's it. We don't do the transformation here because most of the transformations are already done in the transformation layer, where we use a different tool for that. But I'm still going to explain how Power Query works. And then we do data model. If the data we are working with has multiple tables and we have to determine the cardinality, we will do the data model layer. And then the DAX engine. This is also be done because when we transform the data, even with a different tool like PySpark or DBT, we still are not going to be very particular about the columns that we are going to generate. We need our data, we need our final output from the data transformation layer to be versatile, to create more visualizations. We don't want them to be rigid. When I say we don't want the data to be rigid, what I mean is, if you think you are going to create a dashboard with a specific columns in your mind, you don't just go for it and straight away create those columns. For example, if you want to create a line chart which shows hourly sales, the line chart shows the sales that are happening for each hour. In the transformation layer, you don't just create a column for hour. Let me draw a table here. So you should not just create a column saying hour and then sales. If you do that, just to create one dashboard, you are going to create 20 or 15 tables, right? And that is not practical. So you don't want to create tables for one particular chart. It shouldn't be rigid. It should be versatile. So instead of creating hours and sales, we just create one table which has a lot other columns as well, not just hour. We have date and time. We just create a table. We just create the data table to have date and time instead of hour. And then after importing, let me see. So after importing everything into Power BI, we can use DAX to create measures, or we can also use filters to get the desired output instead of creating one specific column just for the hours. We can use DAX here in Power BI. So we still use DAX for minute calculations in Power BI. So we can have versatility with our data. That's the point I want to explain. And then we have reports. Obviously they are done, and then deployment is also done. Just this layer will not be done. Just the data ingestion will be done, not the transformation in Power BI. I think you got that part. And now talking about the Power BI architecture, we all know about Power BI desktop. I think a few of you already know about Power BI service as well. If you don't know, we have Power BI desktop where we install the application on our machine and we work on the data, right? So basically, Power BI desktop is our development environment where we develop the report, we work on the data, and when we create the report. And there is something else called Power BI service, which is actually a cloud service, which is Power BI basically on cloud. So the difference is on Power BI desktop, we import data, transform data, build models, and then create reports, right? And in Power BI service, after we complete a good dashboard, we deploy it into the production environment. After we get a dashboard, we just click on an option called publish. When we click on that, we publish our dashboard on Power BI service, which is Power BI on cloud. And from there on, we can share that dashboard to people in our organization so they can have access to the dashboard as well. Power BI service is a cloud platform that is used to share dashboards and to schedule refresh and to manage access. When I say schedule refresh, what I mean is if our data is in import mode, well, I haven't explained about import mode yet, but just remember this. The data we use for the dashboard sometimes can be in real time, or sometimes it has to be refreshed after a certain duration to update the data. So what we do is we can configure schedule refreshes. We can schedule it for every 5 minutes, for every 1 hour, for every half an hour on Power BI service. It has that option. So it refreshes the data and updates the reports with the latest ones. So we can do the schedule refresh on Power BI service, and we can also manage access. When I say manage access, we can control who can view it, who can edit it, who can share it, all that stuff. When we deploy our dashboard from Power BI desktop to Power BI service, if the data that we are getting from the data source, if it is a cloud data warehouse, we don't need to do anything. We can just publish it right away and the dashboard works. But in case the data source is on our local machine, for example, if data source is a local SQL database that is stored on our machine and not on a cloud data warehouse, or a CSV file which is also saved in our local machine and not on cloud, Power BI service cannot access the data because that is in our local machine. And in that case, we have something called gateway. We install a gateway service to make these on-premises files or databases to actually able to connect to Power BI service. So it basically works as a bridge between on-premises data source and Power BI service. Now, let's talk about storage modes. Talking about storage modes, when we connect a data source to Power BI gives us two options to choose. One is import and the other one is direct query. If we chose import, Power BI gets all the data from the data source and store the data locally inside Power BI. And Power BI has an in-memory engine which is called VertiPack, and it stores all the data in VertiPack. To spell it, let me spell VertiPack so you get the spelling right. So that is how it's spelled. So this is the in-memory engine in Power BI where Power BI saves or stores all the data that it gets through import mode and saves it locally. And whereas on the other hand, when we chose direct query, Power BI doesn't get the data from the data source. The data still stays there. I mean, even in the import mode, the data stays there, but it just gets a copy of the data into Power BI and saves it. But in direct query, it doesn't store the data locally at all. It is still in the data source only, but it is connected to the data source. So on import mode, when you run any calculations, you know what? Let me draw a diagram so you'll get it clearly. So let's say this is our data source and this is Power BI. So let me name it. This is data source. This is Power BI. Okay. Now, when we connect this data source to Power BI on import mode, and let's say this is data. This is data source and this is data. This data is copied and stored locally inside Power BI. This is how import mode works. And on the other hand, when we use direct query and connect the data source, say data source, Power BI, the data will still be in the data source, will not be copied locally into Power BI. That's clear, right? Let me also say this is direct query method. But the major difference here is when we do a calculation, when we run a calculation in Power BI on import mode, let's say a DAX calculation, that calculation is executed locally inside Power BI itself when we use import mode. Because we have the data locally, so the calculations are done locally. But on the other hand, when we use direct query and we did a calculation inside Power BI, that DAX formula is converted into an SQL format. Let's say, to be precise, a data source understandable format. If it is a SQL database, that will be an SQL query. So that DAX will be converted into SQL query and executed inside data source, and then data source returns the output to Power BI because data source is only place the data has. So the data is stored. So that is how direct query works. And because of that, they both have their trade-offs. Now let's talk about the importance of direct query here. When we use direct query, whenever the data in the data source changes, the changes will be reflected directly inside Power BI as well because the data is in real time. Whereas on import mode, when the data in data source changes, the data in Power BI doesn't change automatically. We have to refresh the data manually. That's how it works. And these are the trade-offs right here. So on import mode, speed is fast. When we run a query, it executes faster because the data is stored locally and it doesn't need to change the calculations or anything into a data source understandable format. So everything is executed locally, and that is why it is fast. The data storage is in Power BI itself, and use cases, most of the use cases. But for DirectQuery, the speed is slow, obviously, because it needs to convert the DAX or any calculations into data source understandable format and execute there and get the output. And that is why it is slow. And then data storage is external and nothing is stored inside. Just the model is stored inside Power BI. And the use cases is real time because the data changes in real time. The data, if the data in data source changes, the data in Power BI changes as well. That is how these two modes work. Now let's talk about the other one, live. We talked about import and direct query, but Power BI doesn't ask you about live because live is separate from these two methods, these two modes. We use live to connect to another semantic model. If you don't know what semantic model is, to be uh, precise, it is just another Power BI model. So using live, you can connect to another Power BI semantic model or any other semantic model like Google Analytics model, anything like that. Let's say you created a dashboard and you published it on Power BI service, right? And you want to use the same semantic model that you used for that particular dashboard into another project. What you can do is you can just connect to that semantic model and work with the data and everything, all the models, and basically everything you can see in that file will be visible in this file as well. So you're just basically connecting to the semantic model. So you can do that using live. I will demonstrate all these three modes. I will connect using all these three modes, so you will get the clarity about them. Now live is medium. The fast is medium here. The speed is medium here. It's not fast. It is not slow like direct query. It is medium. Data storage is external model because the data is stored in the external semantic model and not local. And then the use case is enterprise. That's how these three modes work. Now let's head to our first demonstration, where I'm going to demonstrate how we can use these import modes to import our data. For that, I have to say something to you guys. I'm going to use a Python code to generate 3 CSV files, which will be our data, our source data. Instead of using files, I'm using this code because this is a lot easier to share with you guys. You can just run it using, if you have Python installed on your machine, you can just run it and those CSV files will be generated and you can use those files. That's it. I'm going to show you how to use that. First, you have to download this source generator file that is available on GitHub, link that I provided. So you download it, and then I'm going to go save that file on C disk, local C, users, and your username. Here I'm going to create a folder with any name. I'm going to name it, let's say, Power BI. Say Power BI source. Power BI source, and here paste it. That is our source generator, the code. And then open PowerShell. From here, like I said, Python is a requirement to run this code. CD, and the folder that we created, which is Power BI. Is it Power BI source underscore source. We're in there. Now type in Python. The name is source generator. Source generator.py. Run it. And this, I just can't open the file. Oh, I spelled it wrong. That's it. Python and the file name source generator.py because that's a Python file. And yes, CSV files created successfully. Now these CSV files will be created at the location where you saved that .py file right here. 3 CSV files will be created. We need these 3 because these 3 are going to be acting as 3 separate tables, and then in data modeling we are going to connect these 3 tables together. So we need these 3 tables. Now we have the CSV files, and another requirement that we need for this masterclass is Power BI Desktop, which is a primary tool that we need for this masterclass. You can download Power BI Desktop on Microsoft Store or any web browser. That is easy. You can download that. And I hope you got this, right? We just need to download the file from GitHub repository from the link that I gave you, and then save it in C drive here in this location. C drive, users, and your username. This is my username, your username, and then the folder name that I created is Power BI_source. You can create your own folder and save it there. And then run it using Python and your file name .py. That's it. And open PowerShell and navigate to your folder that you created. I'm basically navigating here using CD. CD stands for change directory. CD and my folder name, which is Power BI_source, and then run Power BI source generator.py, which generates my source data. That's what I did. That's it. We don't need PowerShell anymore. We close it. Then the first mode is, let's say, get source data. No, not mode, sorry. So we click on get source data. Now we search for CSV because first I'm going to show you how we import CSV files. Click on text CSV, import. From here we navigate to the files that we need to import, which is Power BI source, all these 3 files, one after another. There you go. We have all the data here. But because this is a static file, Power BI doesn't ask for the options import or direct query, because obviously this is imported. This data will be stored in Power BI. It is not in direct query method. So when we'll click load, it just loads the data. Right here. On the right pane where it says data, you can see all the data that we imported. We imported sales data, all the columns here, right here, which includes customer ID, order date, order ID, product ID. All the data is here. And if you want to add the other 2 tables, click on get data, the same thing, CSV, and navigate to the files that you want, which is products next, load, and that will get loaded. Now we have products and sales data. That's how we import CSV, static files. CSV, it can be CSV, Parquet, JSON. Can we? Yeah. Those files. Now, this is easy. But to demonstrate import and direct query method, we need something else. We need to save this data in a database or data warehouse. For that, I'm going to close this. Don't save. I'm going to open my database, PostgreSQL database. that I initialized already on my PC. If you want to use the same setup, I mean, you don't need to do this demonstration, this practical part. You can just leave it, but you already know how to import the data, right? You can just leave it. But if you want to, seriously want to demonstrate, do this practical stuff, you can initialize this whole database. I guided I guided everything step by step to initialize this setup on SQL Masterclass. I think it is. I think it is SQL full course. That in that video, you just go to the part where I actually did the setup initialization, and you can set everything up. So this is the database. Here we have Postgres and schemas. I'm just going to use the same public schema. Oh, wait. Let me create a new database. I'm going to create a new database. Call it store. So that creates a new database. Here, schema. I'll just leave the public schema and right click on tables and import data here from CSV. Browse. And I'll import the CSV files as tables into this database. So we can, so I can demonstrate how to connect a database and the import and direct query methods. Direct query modes. Right here, it should say Power BI source. Sales data first. Next. Do I need to change anything? No. Proceed. So that creates our first table, which is sales data. Do the same thing with the next two tables. It can be any database, by the way. It doesn't need to be Postgres, and it doesn't need to be running on dbeaver API. It can be any database, any API. We just need to import the data as tables into the database. So you can see how we can use import and direct query methods there. Honestly, you don't need to do that. You can just, because I'm going to demonstrate it, you can just see me doing that. That's enough. Proceed. So we have all the tables, all the three tables here saved in the database. Now let's open Power BI again. Power BI. Get data from data sources. Here, because my data is stored in a PostgreSQL database, I'm going to search for PostgreSQL right here, PostgreSQL database. Click on that, connect. It asks for server and database. Server will be right here. So the server for this database is localhost 5432. I'm not sure if you can actually see that, but here, right here, it says localhost -5432. That's the server. Localhost 5432. And the database we created is store. And these are the details. We don't need advanced options here. But when you see here, it says data connectivity mode. I hope you can see that. Right here, it says data connectivity mode, and it gives me two options, import and direct query. That's how we chose it. And we already talked about the differences between direct query and import mode, right? And for this masterclass, I'm going to use import mode just because I'm going to turning my computer off and on a few times while I film this masterclass, because it's going to be quite longer, but not too long. So I'm going to use import because direct query, I might face an issue for that. Because if you use direct query to connect to a database, the database should be turned on all the time to get updates from it, or else the data, it crashes. So here I'm going to use import method. That's how we choose it, basically. And click OK. It asks for the username and password. So that is the username and password for the database right here. Let me show you. Edit connection right here. So it says the username and password for the database. So my username is Postgres and password. And connect. Okay. And that's it. We can select all the 3 tables from the database and import them. Load. That's it. We get all the data from all the 3 tables right here. And because this is import mode, when we use import mode, we have to manually hit refresh button to get the updated data. I mean this button right here. This refreshes all the tables and fills them with the latest data. We click refresh and the data is refreshed. That's how it works. That's how we get the data from a local database. We can do the same with cloud data warehouses like Snowflake. It is pretty easy with Snowflake as well. I've done a lot of projects on Snowflake and I have this connecting Snowflake to Power BI in a lot of my projects. So if you want to know about that, you can just check one of the Snowflake projects where I include Snowflake and Power BI. So you can just see how I connect Snowflake to Power BI. That's pretty easy. We just need to enter the server, the ID thing, and then the warehouse name. That's it. And when we click on OK, the same thing we saw when we click on when we connected to this database where it shows all the table names, the same thing when we connect to Snowflake as well, it shows all the tables that is in that warehouse. It is that simple. The connection method is different, but most of the after connection, everything is same. Even if I connect to CSV, I still get these 3 tables work in the same way. And now since I connected with the database, it is still the same 3 tables. They both in the both ways, the data works in the same way. So I demonstrated 2 modes of connections, import and direct query. But the third one, which is live, where we connect to another semantic model, I'm going to do that in a different topic, but I will demonstrate how we can connect. But right now, just to go with the flow, I'm going to do that a different time. But I'm going to show, in the same way, we click on get data, and here we type in Power BI. Let's say Power BI semantic model. Right here it says, when I type in Power, it says Power BI semantic models. When we click on that, if we already logged into our Power BI service account, it pops up with the options here when we click on connect. But I haven't logged in yet. But for this Power BI service account, if you want to, try it yourself, you need an organizational email like your school email or your company email. So you can type in here. It should have the Microsoft account to log in, and you have to log in here, and then you can work with it. You cannot use your personal Microsoft account for this Power BI service. It doesn't allow it. It should be an organizational email, and you log in into it. You can publish your dashboards or your semantic model into it. I'll do that, but not now. Our next topic is data ingestion and Power Query. And like I said, Power Query is an ETL layer of Power BI. And we mostly don't use Power Query in modern data engineering because we use the other tools. But if the project that you're working on is primarily focused on Power BI, we still use Power Query there as well. So I'm going to show you how Power Query works. Let me open Power BI for that. So we already have the data that we need here. And to open Power Query, from here, we can just click on Transform Data. This option right here, click on it. And this is Power Query Editor, like it says here. And here, on the left pane, this one, we have, let me make it full screen. So on the left hand side, left pane, we have our data listed. We have public customers, public sales data, public products. It says public because that is the schema name that our tables are stored in the database that I extracted the data from. And at the center, we have the data preview. Now, right now it is the customers table is selected, so the customers data is here. It is sales data. And on the right hand side, on the right pane here, it shows all the steps that are applied on the data. Right now there are only two, navigation and source. And whatever the transformations that we do here will be reflected or will be added as a step on the right hand side here in this pane. So let me do a simple transformation and see what happens. So I'm going to select sales underscore data table first and make sure the schema is correct, the data types and stuff like that. Firstly, the data types for order ID. Right now I think it is whole number. Yeah, so it is whole number. Right here it says the data type is whole number. For the IDs, here's the thing. It doesn't need to be whole number. It can be a string as well because we use whole numbers or integers or decimal data types when we possibly use any mathematical operations on that column. And for IDs, we don't do any mathematical operations because they're just IDs, right? So it can be whole number if you want to leave it, or we can switch it to, let's say, text, a regular text. Either way, it's the same thing for IDs. So I'm going to switch all the IDs from whole numbers to text. When we read the data from a source, Power Query just assigns a data type to it automatically. If the data that the column has integers, it just assigns the data type accordingly. It doesn't care about the column names because it's a machine, right? So yeah, for all these columns, I'm going to assign text because they are just IDs. And for order date, it says whole number. It says it is assigned text for that, which is not correct. It's supposed to be date time. When I switch order date from text data type to date time, I got this error. This step results in a query that is not supported in DirectQuery mode. And I forgot to tell you guys, I switched from import to DirectQuery method just to show you something called query folding. So to demonstrate it, I switched the import method from import to DirectQuery again. So this error is because I am using DirectQuery mode here. So I'm getting that error because there is a mismatch between the data source and the data type we are choosing here. And like I said, in direct query mode, whatever the calculations or the transformations that we do in Power BI will be converted into an SQL, execute data source executable format, which is SQL, and then execute there. And that is why there is a mismatch between that, and that's why we cannot switch that to date time. So I'm going to leave it text for now. Or let me just say Control plus Z. Oh, it doesn't change. Okay. Text. So it says change column type. The select column has an existing type conversion. Would you like to replace the existing conversion or replace current? So it is back to text again. And the region is text, sales, amount, decimal number, because it has the decimal points to it. and the quantity is whole number. That makes sense because that doesn't have any decimal points. So the data types are correct. And now we can remove null values just by hitting on a column right here, the arrow one, and click on remove empty, and that removes all the null values. And we do that the same thing for all the columns. Remove empty, remove empty, remove empty, remove empty. Now all the null values in any of the column are gone, and all the transformations are shown right here. And now I'm going to show you, because this is in direct query mode, whatever the transformations that we do are converted to SQL, and those queries are executed in data source. Yes, we can actually see the SQL query that is sent to the data source by right clicking on one of the steps here, which are the transformations that we done on the data, and clicking on view native query. When we click on that, we can actually see the SQL query that is executed in the data source. See that this is a SQL query that will be executed in the source. And because this query is to filter out the null values, it checks if any of the columns have the null values and take them out. So that's how you can check it. That's one of the options. If you want to debug anything, you can do that, or whatever we do in Power Query is converted into something called M language. When I say M language, M doesn't abbreviate to anything. It is just called M language. And the language is, you can see the language right here. So this is M language. And by the way, this is one way to debug your errors that you face in Power Query. When I say that, you don't need to be good at typing M query or M language. You just need to know how it works. You just need to be able to debug using M language. That's it. You don't have to code in M language. And that's pretty easy to see what's happening with M language here. So basically, like I said, these are all the steps that we applied in Power Query, and they are all in sequence. Yeah. See, the first one is source, navigation, change type, and filter rows, and all of the following steps are also filter rows where we took out the null values. So when we click on one of them, how this M language works is, it shows the transformation right here, transform column types. So this is basically changing the column data type. Yeah, and at the beginning it shows public sales data, which is the data source, which is the data that we are working with, and then it shows the order ID, which is the column, and we're changing it to type text. And then we're also changing product ID to text, customer ID to text, and order ID as well to text. That's it. And when we go to the next step, in M language, every single step is connected to the step prior to that. And here, the step prior to the filter rows is change type. And that is connected using the name of the step right here, hash change type. That's a step prior to that. And then this is how it checks if the data has anything that says null, or the column. The column, anything that says null will be taken out, or empty columns are taken out. That's how we actually read the M language. So if you face any errors, if you think any steps that you applied are not actually applied in the right way, you can just debug with M language or the SQL query if you're okay with that. That's how the transformations are debugged mostly. Now let's do one more transformation. A few more, just a couple more transformations, and then we'll end this Power Query demonstration. Because Power Query is easy, we can just do transformations using the UI, and the M language is generated automatically by Power Query. You don't need to type in. Now, what I'm going to do is I'm going to select region here and switch to transform tab on the top and click on format and trim. So what trim does is, I have to move it to the bottom, trim text. Okay. So what trim does is, if there is any empty spaces in the text at the beginning or at the end of the text, they will be removed. Because these are regions listed in the region column. So there is a chance to have empty spaces at the end or the beginning. So they will be removed using trim. And by clicking on the same option, format, I'm going to choose capitalize each word. What this does is, because these are just the regions, I'm going to turn every letter that the word starts with to uppercase from the lowercase if there is any. And this transformation also is not supported in DirectQuery mode. So I'm just going to, cancel that as well. So you can just remove any step from the list of steps by just hitting on this cancel icon, and that will be removed. Just like that. So yeah. And if you want to remove duplicates, I'm just showing you how the most used transformations are done. I cannot demonstrate all the transformations here. There are a lot of ways to do transformations, and I'm just showing you the most used ones. And now the most used ones also include removing duplicates. So for that, I'm going to choose order ID and click on remove rows and remove duplicates. This will remove duplicates because order ID doesn't supposed to have any duplicates in it. So when we click on remove duplicates, that will remove all the duplicates. And as you can see, because I use DirectQuery mode, I am facing a lot of problems here. You see, it doesn't allow me to do half of the transformations that I want to do. But if you use import mode, you can do all these transformations. But just to demonstrate how the view source, how this option works, I just imported this in DirectQuery mode. But if you don't want to face any of these problems working practically on the data, we just import it in import mode. Okay, so that is not supposed to be done. So I'm just going to remove it as well. For the record, what I'm going to do is I'm just going to cancel this whole thing. I just shown you how the SQL is generated, right? So I'm just going to close this file and import the data again in import mode, because the next transformation that I'm going to show needs to be in import mode. So let me do that. Okay, now I used import mode here. First thing I'm going to do is switch the data type of order date from text to date time. And it works perfectly this time because it is in import mode. And from here on, we can actually separate the date from date time. So we can just create a separate column just for the date. And to do that, we chose the order date column and click on add column and click on date and choose date only. And that will create a new column just for the date. And I'm going to name it order date clean. And by the way, to rename it, I just double clicked on it. There you go, double click. Okay, so that's how we can actually separate date only from date time column. And finally, I'm just going to demonstrate one last transformation that is mostly used, and then we're done with this topic as well. And that is append versus merge. You know what append is, right? We can append another table with the same schema as the sales data to this table. So you know what append is? There is the sales table, and the table we are appending it will add at the bottom. We just combine at the data in the second table to this table at the bottom. So it's basically like combining it. So we can append another table to this table, but the table that we are combining with this or appending with this should have the same schema, should have the same columns and same data types. So we can do that. And the other one is merge. We can join tables, and I'm going to demonstrate how. Just like in SQL, we can join tables as well. So to join tables, I'm going to join sales with customers maybe. And here, when we switch to Home tab at the top, we can see these two options. If you want to append another table, I cannot demonstrate append because I only have one table here, and I don't have the same another table with the same schema, so I cannot do that. But you know, it is easy. And we have another option called merge queries right here on the top. When we click on merge queries, this table is already chosen, the sales one. We are going to choose another table, customers, to merge with this one. And here we can choose the mode that we want to use to join these tables. And I'm going to use left outer, all from the first matching from the second. Left outer join. And there should be a column that matches in both the tables, right? And the column that matches in both the tables is called customer ID. But when I select customer ID on both the tables, it says select column of the same type to continue. But here, these two columns are of different data types, it says. So we have to change that. So let me cancel that, go to customers, and turn this customer ID from whole number to text. So now it has the columns are of same data type. So let me go back, merge queries, select the customers table, left outer join. Now it shows customer ID on both the tables, and that the OK option will be activated. Now click on OK, and that will merge these two tables. Right now, after we merge, it only shows only one column will be visible. To make it big, we just have to click on this button here and click on OK, and that will expand the whole table. And there you go. That's how we can join two tables in Power Query. See, the customer ID 1051 is matched with the customer ID 1051 on the customer table. But we don't need these transformations. So after we are done with all the transformations that we want to do, we can just click on close and apply button right here, and all the changes will be applied. But right now, I don't want to join these two tables. So I'm just going to cancel all the transformations. We don't need any of that. Just going to remove the join, merge queries, and then renamed column. And I think that's it. Yep. Now click on close and apply. And all the changes are reflected onto the data. And here in the sales data table, we created another column, which is order date, which we can see right here. And perfect. That's how it works. Okay, with that, we're done with this topic as well. Let's move to the next one. And for our third topic, we have data modeling. So for data modeling, if you take a close look at our data that we have three tables. And you can see these three tables are related to each other just by looking at it. These three tables represent the same data, but we have three different tables because instead of creating one giant table which looks messy, we create multiple tables, and we use a schema for that. And the most used model is star schema, and it depends on what situation you're in, but the most used one is star schema. I use it mostly, and yeah, so this is how star schema goes. There is one fact table and there are multiple dimension tables that are connected to one single fact table. And right here with our data, sales data table will be acting as our fact table, and the rest of the two tables, customers and products, are going to be acting as dimension tables. And to model this data, we have to head to model view tab right here on the left pane. Click on model view tab, and here we can see all three of our tables. And sometimes Power BI automatically assigns these relationships between the table. So I'm going to delete them for now because I want to demonstrate how we can create the relationships. So I'm going to delete them. So we have three tables, and the difference between these fact tables and dimension tables is basically fact table stores the transactional data and the dimension tables stores the descriptive data. Let me be clear here. So the fact table, the data in fact table is numerical and large, and it grows over time. And whereas on the other hand, the data in dimension tables is descriptive, smaller, and stable. It don't grow like the fact tables. It will grow, but it don't grow as fast as the fact table, because the fact table stores the transactions. Every time a new transaction adds to the data, this table grows, but the dimension table doesn't grow unless if it is a product table. So this table stores the description of a product, right? So if a new transaction gets added, this table grows, but this table doesn't. It only grows when a new product gets added in through the transaction. That's why the dimension tables are called as descriptive tables and the fact tables are called as transactional tables. Okay, we have three tables now. To connect these three tables, like I said, the two dimension tables will connect to one single fact table, and these two, products and customers, are two dimension tables we have, and this is one fact table that we have. So let's connect product ID first. Oh, I think I just, oh no. I think I have to convert the product ID as well to text here. I forgot. So let's do that using transform data. Go to products. Let me be quick here and turn this into text. Close and apply. Perfect. Head to model view. And now drag the column that connects sales data to products table. So that is product ID. I'm going to hold the product ID and drag that and drop it on the product ID in the sales data table. And now this panel will be up here when we drag and drop it. Now this will show you two options: cardinality and cross filter direction. And the most used cardinality is one to many. It shows the relationship. Now each product ID in products is in relationship in relation to sales data is one to many. One product ID in products table is related to many product IDs in sales data table. That's how it relates. And mostly the relation should be one to many. If it is many to many, most likely you have a problem with your model, because it should be an optimal model has one to many relationships. So if it is one to many, your model is correct, and the cross filtration direction should be single. So it shows the direction of the way the filter goes through. So we're basically connecting two tables. And now these two tables doesn't work as two separate entities. They work as one single entity. Whatever the filters that are applied on sales or on products will be reflected on sales data. That's why they are they're related, and that is what the cross filter direction determines. So if you said single direction, the filter passes from products to sales and not from sales to products. And same with the customers. We drag and drop customer ID and we choose the cardinality, which is of one to many, and the cross filter direction is single. Save it. And that's how we connect the tables using relationships. And that's how data modeling works. And hope you got the concept right. Instead of having one giant table that has all the data in it and make it messy, we just segregate the data into multiple tables into a particular model, and the most used one is star schema, which we used here. And then we segregate the data into two dimension tables and one fact table. Fact table stores the transactions and dimension table stores the descriptive data. Then we connect that in data modeling tab. Okay, that is perfect. Let me save that. And there are trade-offs with the cardinality. You know what cardinality is, right? And here's the thing with cardinality. Cardinality also defines the performance, or also determines the performance that our model will have. Let's take the column country. Country's cardinality is low because country can have multiple duplicate values in that column. So the cardinality is low and performance will be good. If the cardinality is low, the performance will be good. So because it is only dealing with a few different types of data. And whereas product name, it can be, the cardinality is medium. So the performance will be okay. Whereas order ID will have unique value for every column, yeah? So the cardinality is high. If the cardinality is high, performance is bad. So it is, should I call reciprocal? Yeah. Or inversely proportional. So the cardinality is inversely proportional to performance. This table, I think we have to use this table in a performance optimization topic, but that's fine. These are the performance, the cardinality affects performance. Next up is topic 4, DAX for engineers. And this acronym DAX stands for Data Analysis Expressions. This is a query language that we can use on our data model in Power BI. We can also do a few calculations with DAX formulas. Now, let me open Power BI. We mostly use DAX to create measures or calculated columns, mostly measures. So when we click on new measure here and select any of the tables that we have, so this small block appears, and here we can type in the DAX calculations that we want to create the measure with. And in the same way, we can also create columns, calculated columns with DAX, just by going to insert and click on not insert, going to modeling and click on new column. And here, so here we can define a formula that we can create a calculated column with. We can do both. And here's the difference between calculated column and measures. A calculated column will be computed at the time of data loading, and a measure is computed only when the query is executed. What I mean is, so if we created a calculated column, it is computed right when we load the data in, because that acts as a regular column in that particular table. Whereas a measure doesn't act like a column in the table. It is just a value, and it is only calculated or computed when we actually use it. So that's the difference between these two. To give an example of a calculated column and a measure, let's say we have a table. Let's take this sales data, but instead of having, let me open transform data, Power Query, not to use Power Query, but to have the whole view of the table. Let's say in this sales data, this table stores all the transactions of a customer, and instead of having sales amount here, let's say we have price of the product purchased. So the product purchased by the customer and the price of the product and the quantity that customer purchased, the quantity of the products that customer purchased. Let's say that's the values that, or the columns that the table have. Now, this table is missing to calculate the total purchase value of that customer of that product, which means price times quantity. Let's say that is what missing here. Now we can create a measure. Now we can create a calculated column. So we can create an extra column right next to that. So it calculates the total sales amount that is done for that product because he or she, the customer, purchased this amount, this quantity of that particular product. And say we create a column for that. So we do that by clicking on new column and name our column, let's say total, or let's say total value. We want this total value to be our column name of our new calculated column. And then we say sales data, which is our table, and we choose the column here, and we chose the quantity first, quantity times the table name again. We don't have the column that says the price, right? So we just say sales amount here, but for our example, that's going to be price. So we do that, and this will create a calculated column. This will create a new column that calculates the total value for each row. So that's how calculated columns work. In the same way, measures work a little different than that. So we choose a table again here and click on new measure. That creates a measure here, but that doesn't act like a column. That is just a value that stores the result. And here, unlike calculated column, which calculates for each row, let's say measure calculates on a subset of rows. So for example, it can be used in situations like calculating total sales, maybe total sales, which will be adding up all the transactions that are done, which will be sum of and sales data, sales amount. So this measure, let me create this because there you go. Now this measure holds the total sales done through all the transactions that we've done. And let's say table. There you go. So that's the total of the sales amount done throughout all the transactions. So that's how measures work. And we can use these measures for filters, or this is one way. We can also avoid using this DAX way of creating this measure just by Instead of typing a DAX code, we can also do that with just the UI by choosing table and selecting sales amount from here, and there you go. And we can choose. We can choose if we want the sum or average or minimum or max right here. But in few cases, if you don't know or you don't find any way to use UI, you have to use DAX. So it's always best to learn how we write in the DAX formulas, because it is not that hard to write any formulas in DAX, but because you just saw that, right? It is so easy that we just say any mathematical operation that we want, let's say average, and it pops up right away. And the table or the columns that we want to select, also we just need to type in the table names first three letters, and the table names with all the columns are popped up here, and we can just select them and create your own logic for the calculation and create a measure. That's how DAX work. Now, the technical terms that we can use to represent these type of actions in DAX are raw context and filtered context. Sorry, row context. Row context basically depends on one particular row, or let's say each row, and the filter context depends on a subset of rows. So that's how it works. What I mean is, remember when we created a calculated column, I said we calculate the total, let's say total sale for each of the row. So that is row context, because that is calculated for one single row, and that repeats for every other row. And there is filter context, which is just we done here, which is like this measure that we calculated, total sales, which depends on a subset of rows, because this one calculates a value for the whole table, which is a set of rows, right? So that's how filtered context and row context works in DAX. Now, let's top it off with a couple more examples of uh, using DAX to create measures. So we have total sales already. So let me just create a couple more measures by clicking on new measure, and let's name this measure as order count. And for this, we are going to count sales data of order ID, and this counts the orders that are done. Then we create one more measure. Now, this is one way to use measures. We can use a measure to create another measure. Now we created order count. We can use that measure to create average order value. Divide total sales, comma, order count. So we used two measures to create another measure. This will give us the value of average order value. Let me click that. So that's total sales. And oh, I created these two measures in a different table, but that's fine. Okay. So we have the total sales, order count, and average order value. We can use these calculated measures that we created as KPIs, or we can use them as filters for another chat, or the chat that we create. So can be used either way. That's how measures work. Our fifth topic is visualization. Visuals in Power BI are not just visuals. They act like query generators. They generate DAX queries to run on data models, then they retrieve the results, and then they render the output. Well, the visual model would look something like this. Any user interaction from the user on the visual will be executed as a DAX query on the data model, and the result will be shown in the chart at the end. That's how the model works. Any interaction from the user will be executed as a DAX query. Now, let me open Power BI. And by the way, the most used visuals or charts in Power BI are bar chart, pie chart, line, table, uh, slicer. Slicers are basically filters that we uh, put in a dashboard so the user can filter the values out. So these things are the most used ones. Did I miss anything? Yeah, I think those are the most used ones. And we are going to create, I'm going to show you how we can create a few of them now. For our first chart, you know what? We first are going to create a few KPIs. If you don't know what KPIs are, KPIs stands for key performance indicators. They are not charts, but they are part of the report. We're just going to show the values on the top. Like the measures that we created, we can use all of them as our KPIs. And to show KPIs, we are going to create a card for each of them. So we click on card, and I'm going to choose the first KPI as total sales. And another KPI, order count, and another one for average order value. So we created 3 KPIs with our 3 measures that we created. And that's it. These KPIs are basically just the cards to display the any measures or any values like total sales, order count, or something like that. They are not particularly any sort of a chart, but they're part of the dashboard. Now let's create a bar chart. For a regular bar chart, in Power BI, we click on this option, clustered column chart. Click on that. If you want a vertical bar chart, we click on that. If you want horizontal, we click clustered bar chart, the other one, the one right next to it. And this one's clustered column chart, and that one's clustered bar chart. Now I'm going to choose a column, product name, and total sales. Okay, there are a lot. So I've chosen product name and total sales for this bar chart. For the next one, and because we connected these two tables already, we can use the columns from different tables in one single chart. If they are not connected, they act as separate, isolated data. But here, they act as, related data. And we can actually create a chart out of those two columns. For the next chart, let's create a line chart. For line chart, it just says line chart right here. We click on it. We can basically choose the columns right away, and most of the times Power BI arranges the values automatically the appropriate value for the y and the one for the x-axis. But if it doesn't, you can change right here in this panel, in this pane. So for this, I'm going to use order date clean, which only has the date alone, not the time. And then I'm going to use the same measure, total sales. Now, wait a minute. Okay, I think order date worked, but that's fine. We got the chart, and this shows timely total sales. And when you create each of these charts, you can choose which value to go on y-axis and which one on x-axis right here in this pane, and also secondary y-axis, the legends and small multiples, tooltips. Tooltips are basically the ones that pop up right here. So when we hover our cursor on something, a tab like this, or let's say a card like this pops up. Those are called tooltips. We can also customize them. Well, this is a masterclass, but this is not, like I said, this is not about creating a visual. This is about engineering it. So because this masterclass is primarily focused on data engineering part, we are not going to deal with the UI and trying to make this dashboard look good. But I'm going to upload another video right after this one, which I'm going to create a whole dashboard on Power BI where we are going to see a lot of charts that we haven't seen in this masterclass, and I'm going to show you how we create that, how we can design it to make them look good, and also a few more stuff that is interesting to do with Power BI. Yeah, but right now, if we select any chart that we create, here, right here in this pane, if we switch this from visual, build visual pane tab to format your visual tab, here we can actually format the whole chart. And these options are different from each type of the chart that you're dealing with. If it is bar, if it is line, these are the options you have. If it is bar, they change. And you can customize everything in this chart with this format visual tab. Here we can customize the x-axis, y-axis, secondary y-axis, grid lines. You see these lines here, so you can take them out if you want to. You can change the color, choosing this one, and you can even change the color according to a condition. If you want to, if you want to change the color with the filters that we choose, we can do that as well. And in general, this is the visual pane. This everything in the visual is about the look of it, and the in general one is about titles, the size of it, the titles, effects, all the other stuff other than looks. So here we can turn the title off or on, and we can customize it. I usually put the title at the center of the chart, like that. And we can actually type the title ourselves and say timely sales, like that. And we can also use conditions for titles, and according to what you want to change the title, you can change it. You can change the actual title. Let's say if your data has something related to the gender, male and female, and you have a filter, and you can change the title of every chart that says every chart according to the filter. If you select male on the filter, you can change the color on every chart to blue. If it is female, you can change it to pink. You can also format it. You can also customize it. So yeah, every option you see, this one here, conditional formatting, you can switch it according to the condition, so it is dynamic. Yeah, these are all the effects. We are not going to deal with this, but yeah, this is how we create charts. And like I said, we're going to deal with this format page in our project that we do in the next video. Okay, so finally, we are going to add a slicer. And like I said, slicers act like a filter for the whole dashboard. So we have to click on this button that says slicer, this option. And for the first slicer, I'm going to choose region in the sales data table. And let's create another one for category. Category is right here. Now, so if we choose any option here, this will be the whole dashboard will be filtered out by the filter, by the slicer. And uh, we can use multiple filters at the same time. Let's choose East as the region and clothing as the category, and both the filters affect the dashboard together. And when I say visuals are not just visuals, they create DAX queries to run. This is what I say. Whenever the user, let's say I'm the user, I interact with the filter and chose East, a new DAX query, a new set of DAX queries execute and gets this result and updates them accordingly. So when we create an interactive dashboard, these things are done behind the scenes. They work all the time. Every time a user interact with anything in the dashboard, not just the slicer. Even if we chose anything from one chart, let's say this one, I'm going to choose from this bar chart. I'm going to choose one product. Let's say this one. It automatically acts as a filter. So everything in this dashboard is filtered out except for the product 20. So that's how the filters or the dashboards or the charts work. Talking about filters, this is not the only way we can filter out. We can by default create a few filters. So the chart always follows them and user don't need to pick any. So if we want to filter this bar chart to only top 5 products, because this is already too lengthy, right? So let's say if you want to filter this with only the top 5 products, we can just filter that. In this pane that says filters. In this pane, we can just click on this drop down, product name. For filter type, we're going to choose top N. We can also use advanced filter where we can do the other stuff, but I'm going to do top N for top, let's say 5. I'm going to say top 5. We can also do bottom as well. So I'm going to choose top 5 here and a value to determine the top 5. We can pick the same total sales as the value to determine which products are justified as top 5, or we can also use any other column than that. But yeah, I'm going to go with the total sales. Apply filter, and now these are the top 5 products based on the total sales. That's how filters work. And these filters are like default. And we can use these slicers as well on top of these filters again. Okay, now that is clear. Next up is topic 6, performance optimization. Let's say we built our whole dashboard and we included everything we need. And then we realize the dashboard is running so slow for some reason. Can be slow visuals, or it can be long refresh times when you click on the refresh, or it can be high memory usage. Can be anything. Because if the dashboard uses high memory, obviously it is slow, right? So it can be any of these performance issues. And there are few steps we have to go through to fix these type of problems. And these are the most common issues that you can face in Power BI. The first one is data loading mode. Like we talked, there are two types of data loading mode. There are, the most used ones, import and DirectQuery. And obviously, if the data loading mode we selected is DirectQuery, it is going to be relatively slower than import because every calculation that we do should be converted into SQL, and it has to do back and forth transactions with the data source where we get the data from. Yeah, so direct query is obviously slower than import, and also the live loading mode is also slower than import. So it can, the first one, it can be data loading mode. If it is direct query, it is obviously kind of slow than import. And the next reason can be high data volume. Yeah, if you have too much of data, and that can obviously slow your dashboard's performance. Yeah, that is one another reason. And to fix that, you can delete the unwanted columns or unused columns for your reports, and that can optimize the performance. So you can do that. And for the third performance issue, we have high cardinality columns. For this, I have to talk about something interesting here. We talked about Power BI using a dedicated in-memory storage system called VertiPack, yeah? And this VertiPack follows a different way, a different format of storing data, and that is called columnar format. And this columnar format is not new. It is used by a few other data file storage formats like Parquet, Avro. But if you never heard of columnar, I'm going to explain you and show you how it works. Let's see. I'm going back to Power BI and open transform data just to show you the table for an example. So let's say we are storing this table, okay? And if this table is stored in a regular format, in a row by row format, when we run a calculation on this data or any query on this data, it goes and searches every row one by one, yeah? But when the data is stored in columnar format, it is stored in columns and not rows. Whereas, let's say, you know CSV files. When you open CSV file, you can see the rows are separated. Uh, the rows are stored separately, right? And because of that, wait, is that correct? Yeah. In CSV file, it is the data is stored in rows. Whereas in Parquet or here in VertiPack, these are stored in columns and not rows. So instead of, when we run a calculation, instead of going and iterating row by row, what it does is it only chooses the columns that are needed for that particular calculation. Let's say my query needs a, only this quantity column, and it has to check the top five, products with quantity column. So it only picks quantity and product ID because we need 5 products. So it only picks these two columns instead of the whole table and searching every single row. It only picks these two columns and searches for the top the top product with the highest quantity. So that's how columnar storage works, and that makes it more faster. That makes the query execution a lot faster. That's how this storage format works, the columnar format. And this way of storing the data makes it not only faster but also compressed. It only takes less storage than compared to the row by row storage format. And there is another thing that I have to talk about. And trust me, whatever I'm talking now is not just theory. I'm going to connect this to the next one, which is the third point I'm going to uh, show you, the high cardinality columns. Now, we know how the data is stored, right? And there is an other way where vertipack follows to compress the data, which vertipack follows to compress the data, and that is the data is converted into integers and then stored in the memory, in the storage. So only the unique values, sorry, it only stores the unique values once. So let me show you an example for that as well. Okay, let's take an example of this region. Okay, so and like I said, these are stored in columns, yes? And region column has a set of data, say east, north, east, east, south, and north. Now, this will not be stored as is by vertipack. What it does is, it turns these values, unique values, into integers. Let's say east, it assigns 1 to east, let's say, and 2 to north, and east is already assigned to 1, so 1, 1, and south as 3, and north as 2, and stores the data like this: 1, 2, 1, 1, 3, 2, like that. To make it, more compressed, instead of storing this whole thing, it only assigns a value for every unique value, and then it stores them as integers. That saves a lot of storage space. So now this is how it stores. And the reason I'm talking about this is to say how cardinality works. Now, because it assigns a unique integer for every unique value, if you have a lot of unique values in the column, the cardinality is high. If the cardinality is high, the performance is low. We already talked about that, right? In here, in the data modeling, we talked about cardinality is inversely proportional to performance. And so we have to be careful of picking columns with high cardinality because they will affect performance a lot. If the cardinality of a column is high, performance is going to be bad because this column has a lot of unique values which has to be assigned with a unique integer, and that's a lot of storage, and that can also be a factor that affects the performance. And to fix it, we have to try reducing we have to try not to use the columns with high cardinality. And that's the solution for our third point. And the fourth one is inefficient DAX. And this is simple. Well, we do use DAX to create calculations, to run calculations. And at the end, if we checked all these issues and you really think none of these affect the dashboard, then that is probably because of your DAX. Then that's the only option, right? And this happens because there are a few aggregations where those aggregations run row by row, so the iterates every row. So some of those calculations include sum x, or it can be filter, and these aggregations run row by row, and because they iterate through every row, that can slow your output or render timing. That's one of the issue. So to find it, you can just search on Google or use any language model like ChatGPT and ask your DAX code if your DAX code is the reason for to make the dashboard slower. So that's our last point that affects the performance on Power BI. And to end it, I'm going to talk about one more thing. Let's say this is a tip to help you debug your performance issues. For that, let me head to Power BI. Here, when we click on View and click on Performance Analyzer, this pane will be appeared. Here, if we click on Start Recording and do any operation you want to with your dashboard, let's say I'm going to refresh all the visuals. If you do that, it shows the time taken for each of the entity of the visual to refresh. So the card takes 52 millisecond and 52 or 53 for all the three cards, and for this one, which is the bar chart, it takes 71 millisecond. So we can actually see which part of the dashboard is running slow and which is running optimal through these times, through these durations they take to refresh. And also we can interact with the dashboard and see the each interaction's time to calculate. So if I click on one of the slicers, let's say this one. There you go. So this shows how long each of the chart took to calculate the result. And right now the highest time taken is by the total sales by product name. This one, the bar chart, to calculate the filter. So that's how we can actually, debug stuff easily. Let me stop that. With that, we're done with this topic. Let's head to the next one. For topic 7, we have Power BI service and deployment. And for this topic, I'm going to jump right into the demonstration part. Let me open Power BI desktop. Here in the Home tab, we can see an option that says Publish. And when we are done with our whole dashboard, we can publish it into Power BI service by clicking on that button. Before we do that, we have to sign in to our Power BI service account first. Like I said, for this part, you don't have to follow along with me because this one needs an organizational mail ID. You cannot use a personal mail ID to sign in to Power BI service. It has to be organizational. And I'm going to sign into mine. But if you have a school mail ID, that's fine as well. School or your company mail ID, you can use that. I'm going to use mine and sign in. Okay, now I'm signed in. Then I'm going to click Publish, Save. I have to pick a destination. And I'm going to pick the default one, which is my workspace. Select. I'm going to say replace because I've did that already. So I'm going to replace the already existing one. Okay, now the file is published, but it says it is disconnected to the data source. And the reason behind that is because the data source that we are using for this semantic model is a local database and not a cloud data warehouse. If you're using a cloud data warehouse like Snowflake or Delta Lake on Databricks, this wouldn't happen. It directly connects to the data source because it is a cloud platform. But here it is a local one. So we need a gateway to connect the data source to Power BI service because that is running locally on the machine. Now to connect this to our data source, we need a gateway. A gateway acts as a broker to send the data back and forth from the data source to Power BI service. And to establish that gateway, I'm going to use Microsoft's on-premises gateway, and I'm going to leave the link in the description. And again, you don't have to do this, but if you in future, if you want to connect Power BI service to any local database, you can use that gateway. So I'm going to leave the link for you guys. And after you download that file, and this is the application that you will end up with, now I'm going to install that. We have to accept the terms first. Install. Yes. Yes. Let that be in the background, and let me go to workspace. Store sales. Now this one. We have to click on the semantic model. And settings. Usually doesn't show anything here, but right now we can see this because I already did that before and somehow it is saved. But if you're doing it for the first time, you don't see anything here. But that's fine for now. I'm going to close this. Open that. Now we have to sign into our account, our Power BI service account. After we log in, this is what we see. If we haven't created any gateway before, we have to click on register a new gateway. And I'm going to talk about this option later. So we click next. And here we have to name our gateway. I'm going to name the gateway as store gateway. We have to set a recovery key. And the use of this recovery key is, remember when I said we have another option that says recover a gateway. So if we lose connection to our gateway, and if you want to reconnect to that, we need the recovery key to recover our gateway. And the recovery key should be 8 characters long. Okay, so I used that name, so we use a different name here. Let's say I'm going to name it store sales. I used it all. That's fine. Store sales is fine, and configure. This might take a few minutes. Now, if everything goes fine, this is what you should see. The gateway store sales is online and ready to be used. After we see that, we go back to Power BI service, and we have to click on this gear icon, settings, click on that, and click on manage connections and gateways. And here, click on on-premises data gateways. You know what? I think we have to create one. We click on new and chose on-premises gateway cluster name, we have to name one. Say store sales. Connection name, connect. Connection type, PostgreSQL. The database I'm using is PostgreSQL, so I'm going to choose that. And then server is localhost 5432, and the database is store. Authentication mode can be basic, maybe. Oh, 0auth, that's fine. Encrypt. And for encrypted connection, I'm going to choose non-encrypted. For this, I'm going to choose privacy level. I'm going to choose none. For username, Postgres, because that's a database username, and password as well. Create. Okay, created, store connect. Now the gateway is ready. Close this. Head back to store sales. Click on the drop down, and from here it already says store sales, which we just created the connection name, and here it asks for maps to. Click on the drop down and choose store connect, because that's what we created, the gateway name, and click on apply. And just like that, store sales gateway connection updated. Your updates to store sales gateway connection has been applied. So you have to see that dialog, and now the error is gone. Now the data source credential shows the data source it is connected to, and we can actually work on that dashboard now. Everything here is now live. I mean, not live, but still, the data can get updated when the data in the data source is updated just by clicking on refresh. That's how we do it. And head to Power BI again and click on this. Click on new file, maybe, or let's say blank report. Now we are going to connect to another semantic model. Click on get data. Here, search for Power BI semantic models, connect. And there you go. If we logged into our Power BI service account, it lists all the semantic models that we have in our account. And I'm going to click on store sales, connect. And just like that, we are now connected to another semantic model that is on cloud. And that's how live connection works. Yep, we have all the data here. Let me confirm it using a table. Select quantity, region. Okay. There you go. We have everything here. And with that, we're done with this Power BI Masterclass. Like I said, we haven't gone much into creating visuals in dashboard, but we talked about a lot of the technical stuff which a data engineer has to know. And I'm going to upload another video which is a Power BI dedicated project where we might go much deeper into dashboard creation and making it look good, and connecting tables, all of that. And right after I upload that video, I'm going to connect or link that video to the end of this video, so you can just navigate to that as well. With that being said, see you in the next video. Adios.